Hey guys, welcome to Code Decode. Today in this video, we are going to cover some very important microservices interview questions. So we will start with what all things we are going to cover in this video. So we're going to cover what are microservices, then we're going to cover why microservices, then pros and cons of microservice architecture, then when do you actually need to use microservice and when not to. So basically the three W's, that is why, what and when will be covered here. Then how does microservice architecture works? Then what are the main features of microservices? Then if you're creating multiple microservices, how will they actually communicate with each other? What are the ways in which you can make them communicate with each other based on your business requirement? Then what is the difference between monolithic architecture, SOA architecture, that is service oriented architecture, or the microservice architecture? What are the difference between all the three? Then most of the companies, what is happening nowadays is they are having monolithic application. Now you being a developer, you are asked to design and modify the monolithic architecture to microservice architecture. If you are asked to do so, it's not that easy. So what are the best practices you should remember and how you should do that is what we are going to also cover in this video. Then which database does microservice based architecture prefer? So there are multiple databases out there in market. So which database will you prefer for your microservice architecture is the most asked questions nowadays in an interview. Then what are the important design patterns that you have used while creating a microservice architecture is also one of them. Then we are going to cover what are bounded contexts. Then when you are all done with your creating your microservices and interacting them with each other, the last thing that you need to do after designing everything is how will you test your microservices that you have created. Then with all these things done, don't you need to secure your microservices? So you need some kind of security, kind of authentication, authorization implemented in your microservices. So how will you do that? So we are also going to cover this in this video. Then how will you monitor your microservices? What are the tools out there in the market available to monitor your microservices that you have created? That is also we are going to cover. Then how would you deploy your microservices? Why containers are a good infrastructure for microservices is a very important interview question. Then how would you deploy these microservices in Docker and how would you deploy these microservices in AWS? So these all things I am planning to cover in this series. If you need to add something, remove something or manipulate something here and there, you have to let me know in the comment section. Just make sure that this is an interview series. So I'm not going to create a tutorial on each of these topics. I'm going to touch each and every topic so that you are capable enough to answer these questions in an interview. If you want tutorial, we have already created before creating this series. It was pre-decided. So if you go to the Code Decode channel, the playlist, you can see there's a playlist here called microservice tutorials. We have 5 tutorials created for you here. Here we have created a basic video which explains everything about microservice. Then how would you implement microservices using Eureka? Then the fault tolerance mechanism, the design principle called as fault tolerance, then a design principle called API gateway. What is it and how to implement it in Java code? Everything and anything is explained here end to end in these videos, which is a tutorial. In these questions, I'm going to cover just the interview perspective part. If you want us to cover the tutorial or if you want that we should take one of the topic out here and create a tutorial on that, you have to let us know that particular topic in the comment section. Then only we are going to do that. So let's get started now. What are microservices? So microservices is nothing but an architecture. So we have seen many kind of architectures, right? MVC architecture, many kinds of architecture we have seen. So microservice is also an architecture where application is exposed as loosely coupled services that can be independently developed, deployed and maintained. Too much of theory? We have already covered this here. So we had a citizen service, we had a vaccination center service, and what functionality we have implemented here is like a co-win site. One person can come to the site and hit your API of vaccination center and check what all citizens are registered at this vaccination center. So this is how we have two business domain. Our business logic runs around a vaccination center where citizens will register. So basically we have an UI. On this UI, what citizens can do is register themselves with an OTP coming on their mobile number, right? So citizens can register themselves and they can also see which vaccination center is available and book their slots. So what we have done in our implementation is we have created two services, vaccination center service and citizen service. These both of these services are loosely coupled because they are independent services here. They are independently developed. They can independently be deployed because this is a Spring Boot application. They have their internal Tomcat embedded into itself. So the two servers are also different. That is why they can be independently deployed, and hence their port numbers were different. One was 8081, one was 8082. So they are independently deployable and maintainable also. If something went wrong while a citizen is trying to add itself to the UI portal, that means there is some issue in the citizen service and not in vaccination center service at all. Then we just have to maintain and troubleshoot the issue in citizen service and nowhere else. That is why they are independently maintained. So each service is referred to as a microservice. So this is our citizen microservice and this is vaccination center microservice. And each service performs a unique function. What is so good about this microservice architecture? So the specialty of this architecture, it is polyglot. And what does that mean? If I have a team which is working on a microservice using Spring Boot, Java, MySQL, there can be another team who can develop another microservice. So the one who is developing Java, Spring Boot, MySQL is suppose vaccination center service. Doesn't mean my citizen service also has to have the same kind of technology in their tech stack, that is Java, Spring Boot, MySQL. Another team can actually work using Python, Node.js, NoSQL. So in today's market, where the market is such a volatile one, it's very difficult to get a team of 5 to 6 people working on the same technology. So this is why most of the companies are actually moving towards microservice architecture, because even people with a different tech stack can work together in one single application. So what is the advantage? The advantage is different microservice can use different version of same programming language. So it can be a case my citizen service works upon Java 11, my vaccination service is still on Java 8 due to some reason. So this is also possible. It's completely fine. The second thing is microservices can use different programming language also. I have already told you my one team who is working on citizen service is on Java, Spring Boot, MySQL. My another team working on vaccination center can be on Python, Node.js, NoSQL. A completely different language, not connected to each other in any ways. Similarly, different microservices can also use different architectures as well. That is all about what are microservices. We will move towards why microservices now. So in case of monolithic applications, there were several problems. So first of all, what were monolithic applications? If I would have created this whole application as a monolithic application, there you won't be able to see different Spring Boot applications. What you would have seen is one single application having citizens as well as vaccination center. They don't have to communicate with each other at all. Everything is one single application, that is one monolithic application. So what was the problem there? Why do I have to do this much of task to decide what is the domain, what are different actors, and decide their functionality and make them loosely coupled? Why not one single application is doing my task? So this was a UI. There can be a one single application, monolithic one, who is doing everything. The problem was that when your code base is same, it is for presentation, business and data access layer, application is deployed as single unit. So now when this is deployed, there is only one Tomcat on which you deploy, right? Now, if something breaks, so suppose citizen is not able to register, even your vaccination center is also not able to do its own functionality. So with monolithic application, if this goes down, of one issue comes, whole application goes down. Secondly, it is very complex to maintain and scalability is an issue. There might be chances that vaccination centers are less to register and citizens are thousands of citizens are coming to register. So this might be hit less number of times and this might be hitting a lot more of time. So you can deploy this in server 1 and you can deploy this in server 2 with this completely scalable server. So as number of hits comes, the number of CPUs or the servers get increases as in when your request increases. But that will not be a case in monolithic one because both of them will be deployed in the same single server, which is a problem. So microservices solve the above problem. Microservices are ideal when the monolithic application needs to be modernized. So this is what I've already told you. Now most of the companies are trying to move from their monolithic legacy application to microservice architecture just to be able to incorporate a faster development and many more things. So for new software development, if the key business driver is to reduce time to market. So suppose your client is sitting on your head and it wants that today your project is started, deliver at least half of the project in next 1 month. So there's a very less time you have to market, to go live. If the scalable better software is what you need, if you need to lower your cost, like if I ask you go and find 10 Java developers, or if I say okay fine, if you don't even get a Java developer, go someone who knows at least a bit of Python and Node.js or something like that, or on vice versa, then you will for sure cut down your cost. In getting large number of people it's difficult, but getting segregated people are much more easier. So if that is the case, nowadays that is why company are moving to microservice architecture. Then if you need a faster development, in monolithic one people is working on one particular service, will also have to work upon the citizen also, because it will be impacted, and because they are all both interconnected in monolithic one. In case of microservice architecture, you have a very faster development, because you have the team of like 5 people working on here, 5 people working on here. So this is a faster development. Also, if you have a cloud native development, in that also case microservices are ideal. So if you have, like, you always have an option to dockerize your applications and move it to cloud, so microservices are the best way to do that. Now each service is independent and gives flexibility to choose the programming language, database, and on the architecture, and hence that is why in that particular situation you should use microservices. Now distinct services can be developed, deployed, and maintained independently. This is already I have told you. What are the advantages and what are the disadvantages of microservice architecture? So let's start with the advantages first, and then we will go to the long list of disadvantages. So the advantages is you are able to use different kind of technologies. So I can't find 10 Java developers at once. What I can do is I can find 5 of them, and I can find 5 of Node Java developers. So it's okay. You will be able to even manage to deliver something to your client in 1 month, because even though you have different technology. Now each microservice focus on single capability, that is an advantage. One team is just have to think in one direction, in the vaccination center direction. They don't have to think much about the other scenarios also. So that is the single focus, and hence increases the capability of the team. They support individual deployable units. So suppose you had production and your vaccination center 1.0 is already there, citizen center 1.0 is also there. Now an enhancement comes, and there is some enhancement in this particular vaccination center service. It says that now please add one more functionality in vaccination center service. If it would have been a monolithic application, you have to get the whole application down, make your changes, and deploy the whole application, which actually includes citizens functionalities also. But in the case of microservice, you don't have to do that. Just the vaccination service will be capable enough to be deployed alone with version 1.1, and citizen can remain on 1.0, and hence individual deployable units are allowed in microservice architecture. Then it also allows frequent software releases. As soon as you make some changes, you can deploy it. You don't have to wait for citizen service to make their changes and deploy it. Ensure security at each service. Here in monolithic architecture, you have to have one way in which you can have the security implemented. In this case, in each of the microservice, you can implement your own security in your own way. So you have even a free hand in implementing the type of security you want to implement in each of these services. One can have outer, one can have auth 2, it's completely fine. Multiple services are parallelly developed and deployed. So I've already told you, I had a team of 5 people here, I had a team of 5 people here, rather than 5 people just working on both of them. So the development task will be completed twice as faster as this one, and hence your time to market will be reduced. Now what are the disadvantages? If it is so good, if it looks so good, there must be some overhead of using microservice architecture. Yes, there are many overheads of using microservice architecture. So what is it? Currently you just have few number of microservice here. I just had a vaccination center and a citizen center. What if my business domain starts growing? Then your microservices also starts growing in number, and managing those n number of microservices is a difficult task. Now communicating between microservices is a complex thing. Why is it so complex? We have done this already using the REST APIs, and it was so quick. We just hit vaccination center once, and we just not get the data of vaccination center. We also get all the citizens who have registered to this vaccination center. Now when a business expands, now suppose there is one logging microservice which is separated from all the microservices. Now when a hit comes to microservice 1, say suppose vaccination center, you can give a call to microservice 2, which is citizen service, no problem, and then you can respond back. But in the meantime, I also want to log each and every request going and coming. So suppose I have a third microservice doing that, but these are independent of the client. So client does not need to wait until you log your things, right? So what you can do is you can make it asynchronous. You can put your data on an active MQ and you can leave it. So whenever your logging microservice is up again, it don't have to wait for its task completion. What it can do is it can pull your request from this queue and it can respond back to you. So this is asynchronous communication. We are going to cover that in few seconds. But these are the chances that handling microservices with different business requirement is a tough task. Third point, increased efforts for configuration and other operations. So here you can see in a monolithic one, what would have been done is one single application is created. It is capable enough to handle everything. Now in microservice, just for creating citizen and vaccination, we also needed one Eureka server, one API gateway, and many more things. So just for creating one application, you had to create 4 different Spring Boot applications and configure each of them with their application.yaml files or application.properties file. So this was so much of configuration you had to do. So that is one of the cons of microservice architecture. Fourth thing is it is difficult to maintain transaction safety and data boundaries. So now your data can move between one microservice to second to third to fourth. It's very difficult to maintain the microservice transactions. And hence we also have few design patterns to do that. But yeah, it's a difficult task. Now, due to decentralized nature of microservices, more and more microservices will mean more resources and hence high investment. So, it looks like, okay, it's so good that our one team is working here, one team is working here, but if you can see, the number of people working also increased. So, where I had a billing of 5 people for client, now I need 10 people's billing for client, and hence it is high investment. Where I needed just one server, now I need 2 servers to be able to deploy my different microservices. Now if I had n microservices, I might have needed n servers and hence high investment. Debugging is a problem because now your data goes from one microservice to different, where if suppose your data got lost in third microservice, how would you able to debug it? It's very difficult task. So debugging is a problem for sure, but if you use the right instruments, like I'm going to tell you in few minutes, then it's easy to debug your issues. Now microservice will need a large team size with the right mix of experience on design, development, automation, deployments, tools and testings. So why is that so? So I've already told you that we need one team for vaccination center, one team for citizen service microservice. Now each of these teams should have one person who can design your database, one who can design your architect your application, one person who is capable enough to do development, one person who is capable enough to do unit testing, integration testing, manual testing, automation testing, everything. So what person you need here is the same replica you need here also. So again you will need everything in double or 3 times. So this also increases the investment cost for you. Now there are so many kinds of disadvantages and advantages. How will I decide when to use microservice and when not to? So when you have a very time crunch, your client is sitting on your head that give this particular application to me within a shorter span of time, then that is the time when you should use microservice, though it will increase your input and increase your team size, but it will for sure reduce your time to market or time to go live. When you need a scalable software, it is always, when will you be able to have the scalability? When you are on cloud. So what particular architecture is cloud enabled? That is microservice architecture. So you should go to microservices architecture when you need too much of scalability. So when number of hits are reduced, you should have less number of servers with you. When a very large amount or bulk amount of people are hitting your application, you should have more servers in place, then you go for microservice architecture. Only in cloud you are able to do that. Also when you want to lower the cost, now you'll ask me, there are n of 5 people here, 5 people here rather than 5 only, then how are you reducing the cost? So when you use microservice architecture, you make your application capable enough to be deployed on cloud. Now on cloud what happens is, when initially few vaccinations were to be registered, so we had suppose 50 people registering every day. It can be handled just by one server. Now, when cases started increasing, 50,000 people started registering to our particular application. For handling this, you at least need 5 to 6 servers. Now, if you would have made it a monolithic application, in this particular second scenario, your application would have been down if just one server was there. To analyze this issue, and if you have purchased your 6 servers at once, and now when vaccination is like suppose at this point of time vaccinations are reduced, so you have to pay for this 6 servers and your cost is 6x times now. So this is why it's always good to go to microservice architecture, deploy your application to cloud, and use their flexibility to increase and decrease the number of servers and resources as and when required, because the cloud works on pay per use. What does that mean? Pay for what you use. If you use one server, pay for that. If you use 6 servers, pay for that. And when again your load decreases, pay for just one server. So this is the advantage of using cloud, and hence it also lowers your cost. So you are just looking at a very small number here that you have to pay for 5 people, but paying 5 people is much more effective than paying for 5 extra servers. So it also increases your faster development. It is the cloud native development which is enabled, which gives you loads of flexibility in terms of deployments and maintenance and monitoring. AWS has lots of monitoring tool available for you, which makes your life much more easier. So that time you should use microservice. So it makes sense to adopt a microservice architecture if you have a very big size of people available for each service, which will require team to develop, deploy and manage. If you have that much number of people, good enough, go for it. The time frame and skills are the constraints. So suppose you are not able to get all the 10 members who can work on Java because monolithic application was done on Java. You have 5 people on Java, 5 people on Node.js. Go for microservice architecture rather than monolithic one. You can divide the people based on their technology and develop each and every microservice based on their capability and not on the skills the monolithic application needs. If fast results are required, you go for that. Choose microservice only if team has experience in microservices, because teaching people microservice is a difficult task and it will give you lots of input in training them. So pick people who know microservice. Do not use this architecture for simple application which can be managed by monolithic ones. So truly speaking, if you have a very simple application who just, like for example, this is a real time example I can give you in my real life. There was an application which was developed and maintained in Excel sheet. What one person has to do is go and add data in Excel sheet, calculate addition, calculate multiplication, various formulas, everything he has to do on its own. Now this can be automated. So what you can do is you can just create a simple application to automate this thing and convert it into application who takes the data, convert and applies the formula and gives you the result to the client on the front end. So this is a simple application. You just need to convert an Excel sheet data into an automated application. So this is a simple part. So you can use monolithic application here. You don't have to go for microservice architecture. It will give you load on your investment part. So you should first ask yourself, do you really need microservice architecture? Because it comes with a cost. So if it really needs that, you have a business need that you have to decouple your services, go for it. That's when you should use the microservice architecture. Now, how does microservice architecture works? We have to cover so many things, the features of microservices, how do they communicate with each other, difference between microservice, which database to be used, multi-database model, which one, what are the, so have so much things to cover, like how to deploy in Docker, how to deploy in AWS, many more things to cover, but I cannot do this in this video. If you want us to create the second part or third part of this video, just let us know in the comment section. We'll create the second part of it. And we have a like target of 300 likes. Once we cover the 300 like target, we'll put the second video on the same. Thank you.